All right, students, welcome into week number 9. So we are more than halfway through our semester and progressing on with our rocks and minerals sections. I apologize for that. So anyway, we all pretty much know what to expect with our sequence of events. A couple things I do need to inform you of. The discussion boards. Those of you who are up to date, I thank you so much. Those of you who have not done them, you need to do them. Okay, it's not optional. It's the participation in the class. Keep in mind that I'm not the only adult school, I'll say, representative that sees the discussion boards. Anybody from the administration, be it assistant principal, counselors, they can come into our earth science class and they can see who's done the discussion boards. And so I'm getting some notifications from some of the counselors saying so-and-so isn't performing, so-and-so is not engaged, and it's getting close to drop time. So don't neglect them. If you haven't done them, get on them, please. Trying to figure out a way to get this volume bar out of the way here. Anyway, so let's just go through the class. Also, I'm going to have to show a few things here. Because also there's a lot of people who have not even begun CK12. And so let me hop in here because I know this is starting off on a bad foot, but there's a couple things I got to remind you of just because I had to go through a whole ordeal today with a student that was dropped from the class and then decided all of a sudden they wanted to participate, which was not going to happen. So on our screen here, it's the basic stuff that we've seen before. And I hope to, science that you have read these. We had the first few weeks of just going over the syllabus and just going over contact methods and how to succeed in the class. And while I do say, and I will continue to say, you can do the work at any point. Now, we do have due dates on them now as a result of what has happened, but this has been up here since the beginning. There is no midterm and there is no final. Therefore, it is vital to stay active and current with the classwork. It also says on the far left here, there are 3 components to each class: discussion board, lecture, CK12. Those things have to be met. If you're not going to be able to come in to the Zoom, you have to let me know these things. Otherwise, it looks like non-engagement to the administration. So with that being said, these are all the familiar things we've seen before. So please take time, refresh yourself, go over them. If you have questions, ask. If you haven't started CK12, start it now because you will be running the risk of being dropped if you do not. Now, if you're watching this, you're probably not one of those people because you're probably up to date on all this. But anyway, so if we follow the link to Module 9, that's what we're in now. And so now I'm going to make this open and published for you. So it is all ready to go. So first and foremost, so now we are discussing sedimentary rocks. Last week was igneous, and you learned all about the igneous rocks. Why there's volcanic and plutonic, how those related to the Roman gods, and what it means to be intrusive and extrusive. The reason we started with those igneous rocks is that they are the parent rocks. They are the ones that sort of start first, and then from there we can go to metamorphic, we can go to sedimentary, and then also that cycle can repeat. And so while not every single rock has to, have the parent of an igneous rock, you could have some sedimentary rocks that come, some metamorphic rocks that come from sedimentary. It is just, we call igneous the parent rocks because that's where the whole rock cycle started from the get-go. And now we're able to sort of intermingle it all the way through. Anyway, so the discussion board here, it goes back to our similar format. So I have a very good primer video here to get you thinking about sedimentary rocks and the different types. Because as we've seen, there's igneous, or sedimentary and metamorphic. But then within igneous, there's plutonic, there's volcanic. One was intrusive, one was extrusive. And there's many different sort of families that sort of come out from that. Well, it's the same thing with sedimentary rocks. And so the main question here this week is, what is the difference between clastic sedimentary rocks, chemical sedimentary rocks, and organic sedimentary rocks? And then I want you to give an example of each kind. If you watch the video, you'll get everything you need from it. You'll be well primed to head on into the lecture. Do not neglect the discussion boards. 10% of your grade. If you're doing, the CK12 stuff and say you're at B+, you're not doing the discussion boards, C+ right there, just from that. from the discussion boards that I don't require much of, just participation. It's our classroom participation. But that is all on you. I'm just making it easy. It is up to you to perform. So if I hop back to my unit here, we have the lecture and the presentation, which we're going to do right now. So if you go in there right now, you will see this video, and it'll be right there waiting for you. This is the Prezi presentation that I'm going to use. So this will be without the lecture. Use this as a study aid for your CK12 stuff. And speaking of CK12, let's hop into it. I'm going to be going over this during our class on Thursday, and so this will be like a reiteration of it. But one of the things that I have to show you again here. So, this one hasn't moved much. But Earth's place in the universe, 19 out of 30 students have done it, which isn't, too stellar. Then it goes down from there. Earth's interior, we had 2 weeks to do it. Now we're going on a full month. These are some of the ones that should be done here. And then, rocks and minerals gets even lower. And then last week's igneous rocks, only 6. And that was a pretty short unit. It makes me very concerned going forward. And so some of you may be getting like emails regarding my concern about that. So let's go into the Earth Science one. You're going to watch me activate our unit right here. So available assignments, we have our sedimentary rocks. I'm assigning it now. So the due date for this is going to be 1 week from tomorrow, or I guess you're going to be watching this tomorrow or whenever it's up, but it'll be due the 18th. I'm assigning that to you. And it is now available for you to get into, actually, no, let me edit this because it's showing it out of sequence here. Let me go into this really quickly. And so I'm going to edit the due date to be the 25th. It'll give you up until the end of March to get it done. And that way it sort of puts it in line with everything else. So if you click on Sedimentary Rocks, we just have these 3 sections and then our Sedimentary Rocks quiz. And so this sort of goes through the whole process. So lithification means turning into a rock. And then we have the classifications on here. Later on in the week, I will probably put up more quiz answers. I got a couple positive responses from that, so I was happy to see that. But pretty much I base that off of views. If a lot of people are viewing it, I'll make more videos like that. If there's not a lot of people viewing it, then I'll answer questions by request. Keep in mind, you can always email me, remind to message me, Canvas message me if you have questions on some of the questions that you get, and I will happily walk you through them. Many students have messaged me on Remind, and what they do is they take a picture of the question, they send it over, and they say, I don't know what this question is asking. And then we work through it together. You are not on your own on this. Like, I am working with you. You just have to contact me and be in communication with me. So, and then we have our Sedimentary Rocks quiz at the end. So the units will have the same sort of sequence here. Articles to read, videos to watch, real-world examples, study aids. You'll have the Prezi presentation, and then that takes you into the adaptive practice, which is required. You got to do the adaptive practice. That is the classwork. This would be like what I would be handing out if we were in class. So it has to be done. Has to be done. And then it wraps up with the quiz at the end. But then we have these different sections. So if I hop back now to our module, I'm going to go back and I'm going to go into our Prezi presentation, and I'm going to start this presentation. So this is one that I found. It is very good, very succinct, and I liked it more than one that I would come up with. So I'm going to use this. So I'm going to present it now, and we're going to talk about sedimentary rocks. So as we move into sedimentary rocks, these are some of the most common. One of the basic things about sedimentary rocks is you have to break down the word sediment. So sediment is just like the breakdown pieces of something else, something that used to be something else, little bits and pieces. It could be organic, it could be inorganic, which we will get to. But the clue was always sort of in the name for some of these, like igneous, the ignite, fire, magma, sedimentary, sediments, and then we get into metamorphic, the metamorphose or metamorphosis, if you will, the changing of. Is what we're going to be dealing with next week. So let's hop into it. So how are these sedimentary rocks formed? So if you go out to the Grand Canyon, if you go out to Bryce Canyon, Zion, or even like Death Valley, you'll see beautiful, beautiful examples of sedimentary rocks. And they are just essentially layers upon layers of different types of sediment that were being deposited at the time. So most sedimentary rocks are formed through a sequence of processes. We have to go through, and you remember this from the rock cycle, we have to take a rock, we have to go through weathering and erosion. So the weathering is like whether it could be a chemical breakdown, it could be a mechanical breakdown, and then the erosion of it is the taking it away. It's being eroded, it's being moved, and then after that stage, after it's been sort of broken down and eroded, you can see from this picture here, like this water and the wind is working on this rock formation to break it down into little tiny pieces. We have the deposition, so it's being carried away, and then usually, if it's like a water source, it gets carried away to deltas, it gets carried away to beaches, and then what happens after that is compaction. So all these layers start to build up and build up and build up, and you can see this in mini form. If you go to the beach and if you stood right where the waves are coming in, and you just stood right where the waves were, after a while your feet are going to be buried in sand, and it's just that continual like rushing up of water, bringing sediments in, is rolling back out, depositing some sediments, coming in, coming out, and it's that process over and over again. So with the compaction, once all these layers get piled on top of each other, the weight of all the rock starts to compact it, and that heats it up, and that sort of melts some chemicals and some different like elements that may be present within the rock. And then those sometimes that melt. Now we're not talking about like magma or anything like that, but sometimes the like biological stuff that's within the rocks will melt and form a cement and sort of hold the rock together. And so that's why we say there's cementation. So that is the process of getting a sedimentary rock. It has to be weathered and eroded. It has to be deposited somewhere. Those layers have to be compacted. And then there has to be a cementation to bring the rock together as one. And so that's the progress or process that we have. If you look at this visual down in here, the one under cementation, all this black area in between, that's whatever cement that is being used to hold this rock together. Sometimes it's mineral matter, sometimes it's biological matter, but it's just like a natural cement that holds it together. Alrighty. And now, sedimentary rocks are some of our most useful rocks too. Now, while we use igneous and metamorphic ones as well for like granite tops or limestone, sedimentary rocks, they are very, very durable, and they're good for insulation, and so they've been used as a building material for centuries and millennia. And so people have used sedimentary rocks throughout history for many purposes, including weapons. So it may sound weird, but like these are rocks that can be easily shaped. So you can almost like shape these into balls and use them as projectiles for like catapults and whatnot. And then spearheads, limestone and sandstone are huge for being used for building materials. If you're ever driving by Cal Poly Pomona and you see like that beautiful building with like the triangle top, which is being torn down actually. But if you walked along that wall and that building, you ran your hand across the wall, you'll see that that's just a very nice sandstone. And so they're very good building materials. And so this is just an example of the Carnegie Library in Jefferson, Indiana. If you went there and once again ran your hand against that wall, you'd find limestone, which is a really sturdy rock, a really hard rock. And that's one of the things about these rocks. Since they've been like cemented and compacted, they're usually pretty hard and pretty dense. And so there are three major types of sedimentary rocks, which is one of the things the video goes over in much more detail. And so the first one is a clastic rock. Clasts are just bits and pieces of other rocks. So these are like large chunks that have sort of been, I shouldn't say sort of been, that have been compacted and cemented together. And you can see like the bigger chunks in it. So this would almost be like a conglomerate type rock. If you remember that from a couple lectures ago, we have these big chunks of other rocks in there. And so you can almost think of it as like a fruitcake type deal where there's like pieces of fruit, within like this cake, and there's like nuts and everything in there. Same thing with the clastic rock. There's boulders, I shouldn't say boulders, there's gravel, there's sand, there's mud, a bunch of different things, but it's different clasts. And then also and that's the big thing with it. It's just made up of other rock, as opposed to like organic rocks, which could be precipitated out of like water or precipitated out of steam. And so with marine animals that have like shells, the shells are usually made of calcium carbonate, which is almost like an eggshell type material. And as the animal dies and that shell sinks to the bottom, or if it finds a new shell and sheds its own and it sinks to the bottom, those will break down, and those shells can form their own rock, or organic materials such as plant matter can be buried in swamps, compacted and heated, and you can get coal, which is a type of rock as well. And so it can be organic in that sense, or it could be chemical. So some of these chemical rocks that we'll look at can be what's called precipitated, meaning like from a gas that's really high in minerals, or just from different chemical processes that come along. You can have a chemical type of sedimentary rock. All right, so let's look at some of these individually. So what are these sedimentary rocks? Or a type of rock that form when particles from other rocks or the remains of plants and animals are pressed and cemented together. That is the best concise definition of sedimentary rocks that we have. So particles from other rocks or plants and animals, like we talked about just a little while ago, they're pressed, they're cemented together, and they give us sedimentary rocks. And one of the key indicators is the layering of these rocks. If you look at these, you can see they're almost like in nice little layers, little films here. And now we also see this a little bit when we get to metamorphics, but we'll talk about that next week. But this is a good indicator of sedimentary rock. So it's just at different points of time, this material, say it was like a sand, it was deposited, and it was deposited to this depth, and so you had that layer, and then on top of it came this darker layer, and it was only going on for a little bit because it's a small layer. Then this other layer comes in, and so you see like these different events coming in, and it kind of this where we had said like geologists were like earth detectives. This is part of that detective work. You look at these different layers, it tells you how long a certain period lasted, how intense the water flow was, what the geological setting was. Were there volcanoes around? Were there plains around? Was it in an ocean setting? This is what sedimentary rocks can do, and this is all the stuff that geologists do, which is pretty phenomenal. Having to unravel a story from something that can't, verbally tell you a story is not very easy. So those are sedimentary rocks. As we move further out from that, the organic ones, which mainly are like coal and limestone, those are the two you're going to see the most often. They are both sedimentary rocks, but they're organic, meaning that they came from a living organism. So organic rocks form when the remains of plants and animals are deposited in layers. So with coal, you have plant material being deposited at the bottom of swamps and stuff like that. That builds up, it gets heated up, and then once it gets compacted and cemented, it becomes coal, and then it becomes useful to burn, which kind of makes sense that plants, whether it be trees or just shrubbery, that can burn. And so when we get coal can burn. It kind of makes sense there. Now with limestone, that pretty much comes from the animals, in some way, whether it be like ocean creatures or just anything that has, that sort of calcium carbonate shell can be deposited and build up into limestone. Now, one of the easy ways to tell that you have a limestone is if you took very weak hydrochloric acid, and I mean weak to the point where you could put on your skin and nothing would happen. But if you put a little bit of hydrochloric acid on the limestone, it bubbles and it fizzes, and it sort of releases that because of the interaction between hydrochloric acid and calcium carbonate. You have what's called a replacement reaction going on there. And then lastly, we'll move on to clastic rocks. I shouldn't say lastly. Next, we'll move on to clastic rocks, because most sedimentary rocks are made up of broken pieces of other rocks, sediments. And so we call those clasts. So a clastic sedimentary rock is formed when rock fragments are squeezed together, and they're usually grouped by the size of the rock fragments or particles of which they're made of. So some of the most common ones are like a shale, a sandstone, a conglomerate, and a breccia. So conglomerate and breccias are almost the same. It just has to do with like being rounded or being sharp. And then some classic rocks have rounded edges, such as a conglomerate, which we have seen before. And then if you took that same conglomerate, which is just bigger pieces of a rock put together, and say if they were more angular, then we call that a breccia. And those breccias occur a lot of the times around shear zones, around earthquake faults, because they get broken apart. To where the conglomerates, those are usually indicative of like water flowing, because the water will smooth those down over time. And so if you see smooth rocks within a sedimentary rock, that's more like a conglomerate. It gives you an idea of the setting it was formed in. If it's angular and broken up, that again gives you an idea of the setting it was formed in, and maybe around a fault zone or somewhere where there was like violent movement. So then as we move on to chemical rocks, so limestone can also form when calcite that is dissolved in lakes, seas, or underground water comes out of a solution and forms crystals. So this kind of rock is just called a chemical rock. So you can have a chemical version of a limestone as opposed to the organic version of a limestone. And then chemical rocks form when materials dissolve in water crystallize. So you have these materials that are dissolved in water and then they crystallize out. Now, sometimes this could be done on purpose. So you can have an area that is flooded with a brine, just like this water that is loaded with certain chemicals and minerals and whatnot. And they'll do this in really hot areas. So that way all the water evaporates and what's left is your chemical sedimentary rock. And now you can also form this out if you think of like caves where there's like stalactites and stalagmites. That's a chemical rock being formed. It's the water moving through, depositing the minerals to leave us with a chemical sedimentary rock. Alrighty, so here's some of the processes that have to happen in order for us to get a sedimentary rock. So you have to have weathering and erosion. That's the first process of becoming a sedimentary rock, because you need to take a rock that already exists and break it apart. Now that can be done by freeze-thaw cycles, meaning that if there's like cracks in the rock, water can get in there. And then if it gets really cold at night, it'll freeze. And when water freezes, it expands. So it gets into these cracks and it expands out. It sort of puts pressure on the rock. It can crack it and it can break it. And then during the day, if it heats up, that melts. And then as the water moves away, it could take parts of that broken rock with it. Now, also, some areas have water or conditions that are more acidic, and this can break down rock as well. So there's both chemical and mechanical ways of breaking down or weathering rocks. And then it has to be eroded. So after it's broken up, the fragments have to be carried away, which is the process of erosion. And it is the process by which running water, wind, or ice carry away bits of broken up rock. And so it's important to keep in mind those three different types of methods. It's not always water. Sometimes it's wind. If you go out to areas where there's like big sand dunes, the wind is essentially pushing these little pieces of rock up against a common area, and sand dunes can build up. And then after a while, those can even lithify and become, a sandstone. Also, ice from like glaciers. Glaciers move and they cut up and they carve the rock. And as they do, they carry those sediments with them, and they can form, once again, sedimentary rocks. So this right here, this picture from out in Utah, these arches can form simply by wind. As the wind blows through these areas and it picks up sand, and sand is hitting against these formations, it acts as like a sandblaster, and it kind of just takes away some of the material and can leave us with some pretty cool geologic formations. Now, next is deposition. So deposition is very important because it needs to collect somewhere. Otherwise, it would just be sediments, sort of strewn out and about. But you can see from the sort of picture here, we have deposition on different sides of like a bank, what we call like a bar or a cut bank. Sometimes this just all goes out to the ocean and it forms there, but also can form in rivers, because rivers, their streams meander, meaning that they don't always follow the same pathway. Like they can cut different pathways through the rock, and so you can have different depositional patterns within the river. But so deposition is the second process of becoming a sedimentary rock, and water can carry the sediment, from small pieces, larger pieces, and then it just sort of takes it along the way. And while it's going, it will hit other rocks. It could break up into smaller pieces, or like a big boulder can just stay in one place. And so there's many sort of avenues that can go down with deposition. But here the material is deposited in layers. So the heavier material sinks to the bottom, and then that happens over and over and over again, and you have these layers build up and build up. And so deposition is the process by which sediment settles out of the water or the wind carrying it. So if you have wind, blowing a bunch of sand, well, the wind can't, just blow forever. It'll encounter something, or the air pressure will change, and maybe the wind direction changes, or maybe there's just no wind that day at all. And if the wind dies out, it will deposit whatever it's been carrying with it in two layers, and those can become sedimentary rocks. And then lastly, or I shouldn't say lastly, next and second to last is compaction. So compaction is a third process of becoming a sedimentary rock, where thick layers will gradually build up. And this isn't just like, oh, in 10 years, you're going to have this much. This takes millions of years. So it's not something that happens quickly. Now, the Grand Canyon, that has happened relatively quick, the carving of it and the cutting of it, but the deposition of all the rock in there took millions and millions of years. So the process that presses these sediments together after they've collected, so you have all this loose soil here, and so it has poor load support, meaning like if you ever try to walk on the beach and it's kind of difficult, that's poor load support. It's not supporting you very well. But after it gets compacted and you remove sort of the areas in between, or those areas in between get filled up with like biological cements or chemical cements, you have now compacted soil. So you have this layer that has been built up and is now load-bearingly strong. And so the process that presses these sediments down together is compaction. And you can sort of see the difference here between the soil density. Loose and not very dense. Then once it's compacted, it is very dense. The material is much closer together and bound by either biological or chemical cement. And so here, the cementation is the final process. So it is the fourth and final process of becoming a sedimentary rock. And while cementation is taking place, some of the minerals in the rock slowly dissolve in the water. So some of these, will slowly dissolve. Some of the minerals will slowly dissolve in the water. They become almost like a gooey fluid, and then they will solidify as a cement. So while cementation is taking place, some of the minerals in the rock slowly dissolve in the water. And then cementation is the process in which the dissolved minerals crystallize and glue together the sediment particles. So they will sort of dissolve, and they're not melting, it's just sort of dissolving away into the water. So it makes the water not just H2O, but whatever minerals it's carrying with it. And then as the water slowly leaves and the minerals crystallize, they crystallize in like a goo. I'm sorry, don't crystallize in a goo. They're like a goo, and then they crystallize into a cement. I was trying to think of a good explanation there. Almost like if you had like if you're making like caramel. So like what you just melt down a bunch of sugar, right? And if you had like other things in there, say if you put like some raisins or some like, that's gross, or like chocolate chips in it or something. I don't know, something like that, something that wouldn't melt. But if you put it in there and you just let it be, well, soon you would have almost like a brittle type situation. And then that would be almost like the cementation of it. So you can see here the circulating mineral saturated groundwater deposits out some of those minerals, and then they crystallize, but it coats some of the other sedimentary pieces in there, and then it just becomes a solid from the cement. And let's hop on back out. And there's our sedimentary rock lecture. Not a very long one, but everything that you'll need to complete your CK12 work. Possibly later on in the week, I'll post some quiz solutions worked out for you. But otherwise, make sure you're doing the discussion boards. Make sure you're doing the CK12 stuff. Please, 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 please. We're 9 weeks in. We're closer to the end of the beginning. Make sure you're staying on top of it. All righty. I hope you have a great week. Contact me with any questions, and also always communicate with me. Thank you very much.